SUPERPAN targets lighter, recyclable panels for EU transport. A Spanish research consortium is developing ultralight composite panels that could help transport manufacturers reduce structural weight while improving production efficiency and end-of-life recovery. The SUPERPAN project brings together composite manufacturer Burka Composites, the Plastics Technology Center AIMPLAS, and advanced manufacturing specialist IDECO. Their work focuses on multi-directionally reinforced panels for structural applications in automotive, rail, and other transport markets. Reducing vehicle mass can lower energy demand, improve performance, and in some applications, reduce operational emissions. It is becoming particularly relevant as transport systems electrify, since lighter structures can support longer driving ranges or reduce the energy capacity needed for a given journey. However, weight reduction alone does not guarantee a lower environmental footprint. Composite parts can be expensive to produce, difficult to recycle, and energy-intensive to manufacture. SUPERPAN is therefore examining the material, production, and recovery stages as parts of the same development challenge. Thermoplastic composites bring recycling into the design process. Many established structural composites use thermosetting resins, which permanently harden during processing. These materials can provide high strength and durability, but their fixed chemical structure makes them difficult to reshape or reprocess at the end of a component's service life. SUPERPAN is instead investigating thermoplastic matrices, which may offer more practical recycling and recovery routes. The aim is to develop panels that meet structural requirements during use while providing manufacturers with better options once the component is retired. AIMPLAS is supporting the project through polymer selection, material characterization, recyclability assessment, and performance validation. It is also working to adapt composite production techniques traditionally associated with thermosetting systems. This involves more than replacing one resin with another. Any thermoplastic alternative will need to meet transport sector expectations for mechanical strength, durability, quality, and safety. It must also be compatible with production targets for cost, cycle time, and repeatability. The consortium is assessing the energy required to produce the panels as part of this work. That calculation matters because the operational gains delivered by lightweight materials can be offset when manufacturing processes consume large amounts of energy. Commercial viability will depend on whether the panels can balance four factors: structural performance, processing efficiency, recyclability, and cost. The project has not yet established that the technology can meet all four at industrial volumes. Automation and process data could support industrial scale-up. Manufacturing development is a central part of SUPERPAN. Burka is leading the panel work using new material configurations alongside its patented dual pull braiding technology. The partners are also incorporating ultraviolet-assisted curing of prepreg materials. These methods are being evaluated as ways to reduce manual handling, shorten production cycles, and maintain more consistent panel quality. Greater control over each production stage could make the technology more relevant to transport manufacturers, which require reliable output across large component volumes. IDECO is contributing automation and digitalization expertise to the manufacturing line. Process controllers will collect operating data, allowing the consortium to monitor production conditions, identify sources of variability, and detect potential defects. This data-led approach could also help the partners determine whether laboratory results can be reproduced under industrial conditions. For manufacturers, that distinction is critical. A lightweight panel may perform well in testing, but adoption depends on whether it can be produced repeatedly, at the required speed, and within an acceptable cost range. SUPERPAN is supported through Spain's 2023 Public-Private Partnership Program, funded by the Spanish State Research Agency, and co-funded by the European Union. Its consortium structure connects material development with process engineering and production automation, with the intention of reducing the gap between research and industrial deployment. The potential business case goes beyond removing weight from a vehicle. Should the technology meet sector requirements, manufacturers could gain access to a composite panel platform that combines lightweighting, automated processing, and improved end-of-life recovery. Before that can happen, The panels will need to demonstrate long-term durability, production consistency, and a competitive total cost. Those results will determine whether SUPERPAN becomes a scalable manufacturing option or remains a promising research stage technology.